Grok means to understand something very deeply. Hopefully, well, you probably won't grok Git by the end of this, but you'll understand the basics. That's my goal. All right. So, yes. All right. So, a case for version control. What is version control? Version control, or it's also called revision control, or source code management. The goal of version control is to do what when you play a computer game and you want to save a state in your computer game so you can go back in case you do something wrong. That's the goal of version control, except with projects. So it allows you to keep snapshots in time over the course of you developing a project so that you can go back to those, or that you can change gears and try something else and combine different ideas, that kind of thing. It's also so that you can collaborate easily with other people. So other people might be helping you out on a project and you want to be able to combine your different things that you work on, and you also want to be able to make sure everybody in the project has the same sort of set of things in the project that are going on. Usually we think of this in terms of programming, but it can also, I had a friend who used version control to do her dissertation. So she was working on it and she wanted to keep track of her progress in the document, and it was basically just a text document. And so she used version control for the exact same way that we would use as programmers, we would use it to keep track of code. Basically to just keep track of changes and be able to go back in time and see what things change over time and revert and combine different ideas. So it's used for those two different reasons, keeping track of changes, collaborating, but it's also can be used when you get into a group with a lot of other people and everybody's working on code and coming up with new ideas and new features. It's used for what's called optimizing a workflow. Workflow is basically the set of things that you do in order to complete something on a day-to-day basis. So, what version control system you use and how you use it greatly affects and influences your workflow and how you get projects done. So, what is Git? Well, it's a version control system that was developed by a guy named Linus Torvalds in 2005 to use on the Linux operating system. Linus is the guy who came up with Linux as well. It's a distributed version control system. What that means is that everybody has their own copy of the system on their own machine. They have their own history of changes that they make. They can do whatever they want on that, and then they can also, as it is distributed out, they can also combine those changes with other people. This is opposed to a central version control system where there's one central database, basically, of the project where everyone takes parts of it and puts back in different parts. But they're centrally located on a server. This is slightly different from that. If you haven't been exposed to any other version control systems, it's probably not an interesting detail, but just to give you an idea of what it is in the grand scheme of things. Oh, and it's used by GitHub.com. So there's a difference between Git and GitHub, although mostly we'll probably we'll conflate the two ideas. GitHub is the website where you can store projects, or I'll describe this a little bit more later, what's called repositories. Repositories are basically the folder where your project is kept. You can store that on a server and use that server to share your project with other people. And that's what we use in this club a lot. We use a GitHub account and different repositories on that account to be able to keep all of our stuff. You can kind of think of it as in the cloud. All right, so some vocabulary. I already mentioned repository. I also would say repo. To fork is to go into your GitHub account, see somebody else's really cool project. For example, the library that we've written. As an organization, we've written this awesome library for you to use on your microcontrollers for Robotathon. You'd see that, and then you'd do something called fork, which is to basically copy that library onto your own account. So you'll have an account. We have an account, you'll go on our account, you'll see our repo, and then you'll copy it onto yours. And this all happens within the sort of bubble of the internet, inside GitHub. A clone is when you download the repository onto your own computer, okay? So it's just basically you create a copy of it onto your own computer that you can then add changes and create your own history. And push and pull is how you synchronize it with the thing that is on GitHub. Okay? So if you're working on you're in a group with two people who are pushing or making a lot of changes to a project, you're both pushing and pulling from the same GitHub repository. Pushing and pulling just means synchronizing. And a commit is what I've been talking about this whole time when I say a snapshot or a specific instance of a change that you want to record. That's just basically what's called a commit. The verb to commit something is also a valid use of that word, but usually you refer to several commits, basically several snapshots in your project as you continue to work on it. Okay, so here are some commands to use the Git version control system on your computer. The $ there indicates a command line. So this is something that you'd open up a command line, those boxes with the blinking cursor, it's all green that you'd see on the matrix, you type in stuff, that kind of thing. So what we're actually going to recommend you use is not the command line. It's going to be a different tool. I'll talk about it in a little bit. But I find this an easy way to explain the most basic commands that you'll ever need to know when using Git. First is the status command. Basically, it tells you everything you need to know about the repository. Then there's the init command, which initializes the repository on your computer. Alternatively to the init command, I don't have it on here, but there's the clone command, as I talked about clone last slide. So that was the way of downloading the code, basically, onto your own computer, making a copy of it on your local computer. Init is a way you don't need to talk to any other external server. You have your own local thing. Add or rm for remove are the commands to make Git as a system pay attention to a certain file. Commit is what I was mentioning before, where you start recording a change. You do a git commit when you want to record a change. And then push and pull are what I just described, which is to push when you push, you sort of throw things up at GitHub, and when you pull, you download them. Okay, so this will make more sense when I actually use the UI that we recommend that you use for GitHub and for Git. This is a diagram describing the lifetime of a file. I don't have that much time right now, so I'm not going to describe this in too much detail, and it turns out you don't need to know this too much if you use the UI. It kind of hides this whole thing from you. So these slides will be available somewhere. I also go into several sort of advanced Git topics when you're trying to merge different changes that your two friends have made. You're trying maybe a friend of yours has been working on the same project, and you've been working on the same project, and you both modified the same line in a file. Then Git doesn't know how to combine the two, and so you as a human have to go in and decide to do it. And that's what's called a merge conflict, that you have to go in and figure that out. This is what it looks like in the file. And these are more advanced Git topics. I wasn't planning on going through these because they're more than you need to know. But these slides will be available, and I do plan on doing an actual further in-depth talk about Git. But I've given you basically what you need to know to understand the demonstration. So are there any questions about what I've said so far? It was a lot. People are thoroughly confused? Sufficiently confused?
Not yet.
Not yet? Good. Okay, so the concept of Git is basically to record changes like you would record a game state. So you can go back and save your game so you can go back and play it as you wanted to before you did something terrible or before you did something interesting. So this is the website, GitHub. This is my account. You're going to be one of the people on your team is going to need to have a GitHub account and create a designated repository for your team, at least one, for the rest of you to then contribute to. You're all welcome to make a GitHub account, but only one is absolutely necessary.
And why is it necessary? Just for ease of us, or are you guys going to be looking into it as well?
Because of what? No, we're not going to be looking into it, but you need to do it in order to get a copy of the library that we put on GitHub.
Oh, you can just clone it too, can't you?
You can clone it directly, but we tell you not to do that, because if you clone it directly and you change it and then you push it, you're changing it for everyone. What we want you to do is copy the library, keep it on your local machine, keep it on your own account, change what you've done to your own account. That way you can do whatever you want to it and you won't affect everyone else. I'll describe that in more depth as I
I
go
just
through.
downloaded the zip file and kind of extracted
You can do that. That will not use Git.
Yeah.
So we don't recommend you do that. I mean, it's totally cool. Like, you could do that. You could just download the zip. I'll describe that in a second. I'll show you where it's talking about. But the benefits of using Git.
Yeah, you don't get the latest stuff. But do you guys change the library often?
It's not just that you won't get the latest updates. It's that you won't be able to collaborate with other people on your team, and you won't be able to commit things and be able to see a history of changes as you work on your project.
It works, but it's not as.
You just won't use Git or version control. I mean, you probably, most of you at least, have probably done something where you've worked on a project and you made iterative changes to that project and you haven't kept track of those changes, and that's a valid workflow. But using Git is another way of doing things. All right, so what I'm going to do is go and fork the repository. The first step is to fork the repository. So this is the location where it is on GitHub. Here's the files right here. And you can see below, this is the README associated with the repository, and it tells you the step-by-step instructions of how to do what I'm about to describe, like getting started with Git. Get a GitHub account. Getting Git on your computer. Fork Rasware. All right, this is the first step. So the first thing we're going to do is fork Rasware. So how do you do that? Well, you go, here's Rasware, I'm going to hit the fork button right over here. That's my account. All right, bam. Now we're at Rob's, not Raz. Was it Raz? Yeah. Before we were at UT/Rasware 2013. Now we're at my account /Rasware 2013. So Rasware 2013 is the library that we've written, which includes an example project and a template project that we suggest you use. And now I've just made a copy of that that's contained within my own account on GitHub. Okay, and so the important thing here is this URL right here. So I'm going to copy that.
Would we create our own repo for our project, or are we going to be working off of the thing that we just forked? Is that where we're going to be writing our code, or are we going to be creating our own files? If you get what I'm asking.
I think I do, but your question should be answered as we continue through this process. It's a good question. All right, so what we just did was fork Rasware to the top. Next, we're going to do the setup for Windows, which involves getting something called Tortoise Git. That's the UI that we suggest you use. This computer already has Tortoise Git installed, right? Yes. Okay. Other instructions here are important to follow. Getting something called Stellarisware, which is the manufacturer's library for the microcontroller. And Kyle Microvision, which is what's called an IDE, Integrated Development Environment. It's basically a program to help you write the program, basically a text editor. And then these drivers are to actually, when you plug in the microcontroller to your own computer so that you can actually program it. PuTTY is a thing that allows you, once you plug in the microcontroller to your computer, you download the code onto the microcontroller, and then you want to talk to the microcontroller, because you want the microcontroller to send you back information about what it's doing. And this is what PuTTY does for you. Finally, download the code. Okay, so the first step is to choose a directory to work in. I'm going to go with this directory. Directory is the same thing as folder, if that confuses anyone. In this directory, I have something called Stellarisware, which is what I downloaded before. You can follow the instructions for getting the Stellarisware and knowing where to put it. And it says right-click on the directory. So this is after I've installed Tortoise Git. I right-click, and I have these options. This is what Tortoise Git gives you. It says to select Git clone. So I'm selecting Git clone. And then I'm going to use my forked repository's URL. And I get that from, it's the URL that I showed before, all the way at the top, right here on the side. This URL is the identification for the GitHub repository. So I want to copy this repository on my computer so I can make changes to it. So that's what I need. All right? I think it was there already, but that was magic. I just copy pasted it right here. Hit OK. Now we get to watch a turtle doing acrobatics. We wait for this thing to download. So right now I'm cloning the repository. I'm cloning my forked repository. First step was to fork it, and then download all the things that I need to download, which included, in this case, only Tortoise Git. To be able to do everything I've done so far, all I need is Tortoise Git. And then clone it, using the URL of my forked repository.
What's Stellarisware for?
Stellarisware is the library that the manufacturer of the microcontroller provides to do very low-level functionality on the board. So give me an example of something on Stellarisware.
The PLL?
What is that?
Initializing the microcontroller?
Initializing the microcontroller. So that's like really low-level stuff that the manufacturer of the microcontroller gives us. In this case, the manufacturer is TI, Texas Instruments. Right?
Yeah. If you're curious about the actual function calls, you can look into the source code of the RAS Lib.
Okay.
Yeah, if you're curious about what it does, RAS Lib, the thing we wrote, sort of, you can think of it as layers. So what we suggest you work on is RAS template. On the same level as RAS template is RAS demo, which is an example of doing all the stuff we provide in the library. Both of these depend on RASware, RAS Lib. And RAS Lib depends on Stellarisware. And this gives an example of all the stuff that you can do with RAS Lib. The useful code that you will write will be in RAS template, which you can rename RAS template. We'll do it in a second. But you can rename it to be like your team name or something. I did RASware using the git clone option, and now I have it right here. This looks like a normal folder, but it's actually secretly behind the scenes being tracked and watched by Git. So any changes that I make will be understood by Git, and Git will pay attention to those and like tell you about how you changed it. So let's do that right now. I'm going to open up RAS template. So this file right here is a project file. And since I've installed, one of the things that when we went through all the list of stuff that you're supposed to install, one of those things was Kyle Microvision. It's basically the text editor that you use to write your programs. It'll also compile them, and it'll show you how to, it'll download onto your microcontroller if you have it plugged in. Okay, so this is RAS template. Here are the source files for RAS template. I'm going to open up main. I'm going to make some change. So I just added this extra line here. And what we're going to see is Git has figured out that we had just added that extra line. Now let's say we're collaborating with another person on our team. I'm on a team with Chris over there, and we're both working on the same project. And I want Chris to see that I just added this comment. Let's see if this comment is not just la la la. It's actually important information for us to write this function in main. And so what I want to do is let Chris see this on my GitHub account. The way I'm going to do that is in the same way that I cloned it. I'm going to go up to the directory where I cloned it. I'm going to again right click, and there'll be these options. And one of them is git commit, which is one of the commands that we talked about before, which is basically to record something. In order to send or push anything up to the server for your other teammates to see, you have to commit it first. You have to basically make an official recorded change in the Git version control system for that folder, and then that can be then pushed up to the server. That, and you can see down here, the Git knows that I've changed this file called rastemplate/main.c. And it asks, basically it has a check mark saying, are you sure you want to commit this? I can uncheck that if I didn't, but I do. And then there's a little message here that I'm supposed to enter in something to describe what I've just done. Anytime you make a commit, you have to add a little bit of English to describe the thing that you just committed. So I'm going to add something like added very important comment. I hit OK. It commits it, and I close. So I've just committed something that's still not available on my GitHub account for anyone to see, but it is recorded on my local computer. So if you just wanted to never collaborate with anyone, you could just continue to commit stuff on your own, and you'd have a history of all the changes that you made, and you could go back and look at them and revert to them and branch off from them and all that kind of nonsense. So it's useful to have on your own computer, but it's even more useful to have it pushed to the rest of the world to be able to see. So we're going to do that now. Exactly the same way, I right-click the folder, I go to, what is Git? What do Git sync? Is that better somehow? I'm going to go and do a push, because that's what we talked about. Some of these commands I'm not familiar with because they're part of the UI, so we can just do the commands that I know. Just do push. There's some options here. I can describe them briefly, but mostly what you have to do at this point is hit the OK button, and that will push it. The first thing up at the top is, it says local:master, remote:master, remote. All right, so there's what's called branches. Basically, they're different paths that you can go on as you work on something. So if you wanted to add some crazy idea to your project, then a good way of doing that would be to make a branch of your project. So you start working, you're in the same folder, but basically there's a switch that allows you to completely just turn off or just ignore the files that you were working on previously and start working on an entirely new copy. You can do that switch between different copies of your project. The default branch is called master, and that's what you see master at the top here. That's the one that you're on by default at the start. If you want to change that, you can. You can always do all of your work in the master branch. That's perfectly fine. And here, in this case, and for 99% of y'all's cases, you will continue to work in this one single master branch. This remote here, origin, defines the default remote that the project was initialized with. The terminology there, remote, basically means URL. Here it is remote repository. The thing that this repository is connected to that's off somewhere else on the internet, or possibly could be on your computer, but in this case, it's on GitHub. So origin, in this case, refers to the default URL, which is GitHub here, because that's how we initialize the repository. Does that make sense? I described? Okay, neither of those things you really need to know. I just felt like explaining them because there's a lot of stuff up here. And all of it makes sense, but it might be confusing to you at first. All I'm going to do here, all this is fine, the defaults are great, I'm going to hit OK. And when I hit OK, what I'm doing right now is I'm pushing to my account. I'm overriding what the repository was on my account with new stuff. In this case, I'm just adding one single comment to one single file. But in order to do this, I need to give credentials saying that, yes, it is okay for me to modify the stuff on my account. So it's going to ask you for your username and password.
Password is password. Got it.
Great. Try it. All right. So we close, we just push, and if we go to so there's a sort of a file viewer on GitHub itself. GitHub is a pretty cool deal. It's like just a website that has a lot of options on the stuff that you can see and do with your project. In this case, if I refresh, you'll see this number here changed from 213 to 214. I don't know if you caught that. The 214th commit was the commit that I just made. The 213 commits previously were all the commits that we made to create this project for you. So if I go to there, I can see this top one was added very important comment. What do you know? That was the commit message that I entered in. And if I can go to the file, it was in RAS template. It was main.c. And there you go. There's the comment. If someone else wanted to see the changes that I just made, all they would have to do is update their own remote repository. Sorry, their own local repository on their own computer, which they would have gotten exactly the same way I got my repository on my computer. So if Chris and I were working on a project together, and I had just done this, and I wanted Chris to see this change, he would clone this repository onto his own computer, and then he would see the changes. Now, what happens if Chris makes an update? I want to be able to see the changes that Chris just made. The way I do that is the same way I do everything with Git. I right-click on the folder, I go to Tortoise Git, and instead of a push, I do a pull. I could do that right now, but it's not going to do anything because nobody's changed my work, and so it's not going to change anything in my project. But if somebody else were to change something, then in order for me to see those changes, I would do a git pull. That's a good point. So when I push to my repository, you recall that it showed me a box that said, enter your username and then enter your password. A box would also pop up. And he'd probably enter in his username and enter in his password, and then it would say access denied. You can't write to this repository, it's not yours, basically, is what you have to say. So in order to fix that, on this repository, I have to add Chris as a collaborator. And the way I do that is I go to this thing at the bottom that says settings. I think, yeah, settings. And then over here that says collaborators. And then I enter in the tag of Chris. And Chris's tag is Gecky. Yeah. Okay. Okay, so actually I said something wrong earlier. I said that only one of your team members needs to have a GitHub account. That was wrong. Every one of your team members who wants to collaborate with your repository on GitHub needs to have a GitHub account. Only one of your team members needs to fork the GitHub account. So the first step that I did at the beginning, where I forked it to my account, that only needs to happen once. Only one person needs to do that. Everybody else just gets added as a collaborator, and then they can all contribute to it. Okay? What time? Okay, cool. 8:33. Holy shit, that was fast. All right. Are there any questions, like any crazy ideas, any comments, smart marks?
So I wasn't really paying attention to the beginning. You just went to github.com and
Yep.
you looked up like Raspberry 2013.
Exactly.
Okay, cool. Sorry.
Yeah, so the URL exactly was, actually it shows it right here, forked from YouTube. So our RAS's account is YouTube-RAS, and then the GitHub, if you just go to our account, you'll probably be able to find it. So this is our page, this is our logo, it's pretty sweet. And Raspberry. And then the fork button is right here. Okay, any other comments? The graphs.
It's just show off the.
I've never looked at the graphs.
Network, quick network.
Graph low graphs. Wait, what?
Right side, we select the graphs.
Yeah,
Right side, quick network.
portable keyboard. I'm sorry guys, it is too much fun.
Whoa,
Because it just wasn't that hard.
that's cool. All right, so this shows you all the contributions to the.
You have to like drag it.
This is what
Oh.
you do.
Over time, like mostly, you can see that was October, this is September. Yee, going back into who's Tony? Who is Tony? Seriously.
I think he might be a RAS Lib.
Oh, wow! You guys have already started this. Holy shit, that's awesome. And let's see. Let's look. Okay, what's today? What's today? October 9th, right, so here's on the chart. Oh, look at this, what is this, Christopher
Oh,
Haster?
that was mine.
And I thought one of you guys had done this. Have you done this? You haven't done this, okay.
Wait, tell me what?
Oh, for
This is Rob's right here, so I forked it.
I forked it from my account.
I forked it from
Oh,
the
you-
browser.
Wait, you forked it to your account?
Yes.
You should be showing them.
Yeah,
I forked it
it's
to
right here.
Use the hidden forker.
It was updated 38 minutes ago. So.
Oh yeah, try refreshing.
What time is it
No,
right
we're
now?
version.
Am I going over time?
Yeah.
Is this, is
Hey,
this-
You have like
Yeah, an
hour.
Yep.
okay, I have plenty of time, okay, cool.
Refresh the page though. Sometimes the graph doesn't refresh for like days.
Yeah, updated a minute ago.
Data. Any other comments?
Yeah, Tortoise Git isn't working for me.
Does it give you an error or something like my sysgit is
Yes.
not? All right, download my sysgit.
Already done it.
Did you
Installed
run into
it?
the problem where it couldn't find the git.exe path?
Yeah, I had that problem, and all I had to do was install my sysgit, the latest version.
Okay, you probably set in the default location.
Yes, I did. Yeah, so I guess that's probably going to be a common problem that comes up. So if you download Git Tortoise and you try and do something with it, it doesn't work, my sysgit. All right, if there's no more comments, I'm going to go into the documentation of the code to show you how to start working on your project. Okay? If there are no more comments, so if there are, speak now. You did? Okay, sweet. You changed it? Okay, cool. So Chris has made a change to my repository. This is just finishing up with like the Git discussion. So Chris has just made a change to my forked repository because I added him as a contributor, and then he nefariously did it like 5 seconds ago. And so what I want to do is see whatever it is he changed. So I do exactly what I was just describing you do. You go right-click the folder, you hit Git Tortoise Git, you go to pull. All of the defaults are fine for now. Does it pull? What did you change?
I
Let's see what you changed.
changed the readme.
The README?
It's really hard to edit files on phones.
What the? You don't have Notepad++?
Just open it with Notepad.
Just right click on that.
You do have Notepad++, but it's a default one. What the?
Exactly. Coolest project.
The coolest project! Woo! All right, this looks like the line that Chris changed. It's pretty rad.
Git diff.
Sure, I've never done that before.
Do that.
Just right click and goes save the in the top.
Diff? All right, so if you wanted to see, like, I happen to have the dude right here who changed the thing, but if I didn't know what the person changed, I was like, what the fuck did this person just do? And I wanted to say diff, I could do diff. Oh, so what I have to do is select,
Oh no, do git diff with previous versions. The other option.
oh, is that an option?
Yeah.
There it
Okay, so it's showing me the one other thing that has changed. Ooh, and then there's this lovely syntax for describing. I'm not getting to that. All right, whatever. It shows the thing that changed last, so that's pretty cool. All right, let me get into actual code. All right, so this is the main.c file. How many of y'all have programmed before? this is the main program that is run, and who knows what's going on? Nobody. Like, it's just sitting there and doing nothing. You have no way to get back control. So you always have to have some sort of protection to not get out of the main loop. Because you want your robot to do something continuously, right? You don't want it to just like stop and do nothing. And so all of the stuff that you will be doing will happen either in this main loop or some initialization above it. Okay, so let's see, what do we want to do? You want to do the LED, right? All right, so there's two ways you can figure out how to do stuff with our library. One is to open up the demo project, which I showed here, right? There's RAS demo, which shows how to use the library, and then there's your project, which you will rename from RAS template, which will use the library. Okay, so I think a pretty neat way is just to look at the demo and see how it runs and what it does and that kind of thing. Whoa. The demo is in the same folder that RAS template was in. By the way, if you wanted to, you could rename this folder to like your team name so you can feel cool or something. And you go to, right, so RAS demo. So all these files in RAS demo are for demonstrating all the different things you can do. Just go ahead and open up the project file so you can run time. This is the demo project. The demo project, just like the template, has a main file called main.c. There's a main function, which is the first thing that gets called, as many of you probably know. This is the first function that gets executed. It starts off at the top. We do something similar as we did before. So main.c of RAS template just did initialize MCU. This guy also just did initialize MCU. It's the first thing it did. And it called this function. Whoa.
Blend was up top.
And it got, wait, what?
Or if you're confused about the, no.
I'm not confused.
Okay.
I'm
In awe.
expressing solidarity with your confusion. Call every is a function that we've defined in our library for your convenience. If you wanted to know, let's see, yeah, if you wanted to know what call every does, the best way to do it in Kyle is to right-click, go to definition,
Yeah, that happened to me too.
go to.
Oh, you have to build it first,
Oh, do I?
and then title it.
Sure. I have to build the library first.
That would have been my directory issue. Go to demo folder.
No.
Sorry, wait.
Sure.
Go to the demo folder and drag sourceware into the RAS where folder. Sorry.
Oh.
My bad. It is Chris's fault.
Sweet. So that was the flurry of motion. Just ignore that, everything works now. The reason it didn't work before is because the layersware wasn't in the same folder as all the other things. So that needs to
So
happen.
we're gonna have to go on our own then?
You can do that. You can also put Solarisware in the top C directory. C:/Solarisware is where it would be. You can also put it in the repository itself. So now compiled. All right, so now you're saying I should be able to go to the... So what I did was I clicked on call every. Call every is this weird function. I don't know what it does. And so I went down and said, go to the reference of call every. And that took me here. And the important thing to note here is time.h. Time.h is a header file that we've defined to contain a bunch of definition of functions that you can use. The descriptions of these functions are above each one in gruesome detail. So this function schedules a callback function to be called repeatedly. The first parameter is callback. That's this guy. It's a function that is called repeatedly. The next parameter is data, which is an argument. I mean, you can read this. Basically, what this function does is it will call the function that you give it with the time that you give it. So in this case, we gave it the blink function. Blink is defined up here. What's your name?
Assure.
Assure? As Assure. Assure?
Usher.
Usher?
Yeah.
kindly told me, blink is defined right up here. So we gave call every the function blink, and we told it to be called every 0.25 seconds. I knew that from looking at the definition just now. So this function is going to be called every 2.5 seconds, which is pretty handy, because then you can do something every second or every X number of seconds. That function is awesome. You don't have to know anything about interrupts, anything about the hardware. It's pretty rad. Okay? And on this function right here, it sets a pin. What is this function? Well, find out. Do the same thing. Go to reference, set pin. This function is defined in another file that we've written called gpio.h. What does this function do? Well, it sets the pin value for a Boolean. So on your microcontroller, there's lots of pins sticking out. You might have noticed this if you started to cycle your board or listen to anyone for a little bit. It probably came up in a couple of other tech talks. There are several pins which you use to plug in stuff. Okay? What this function does is set one of those pins. Which pin? Well, you specify it right here. To what value? Either a 1 or a 0, or Boolean, which is true or false. True being 1, 0 being false. False being 0. You set it to that value. Okay? Blink will call set pin, which sets pin underscore blue, which is a specific pin on the board, to this value, which is defined right here, int, which gets toggled every time this function gets called. So every time that function gets called, it will set the pin to a value and then flip the values. So if it was true before, now it becomes false. That's what the knock there does. Then the function 0.25 seconds later will be called again. It's 0.25 seconds later, right? And again, and again, and again. And it'll blink it on and off. Does that make sense? Okay, so we've gone through, what is that? 3 lines of the main function. The remainder lines call other functions that are defined in the demo. So we can go through the first one. Basically, this sets up a menu. And then the first function in the demo, UR demo. That's probably not that fun. Let's talk about motors. Okay, so init motors is, where is that defined? Oh. Ooh, that's defined here. Motors. Functions in motor demo. Okay, there's a motor demo.c file over right here. Oh, hey, there's the function declaration in there. Here's what it does. It calls some function called setMotor. Okay, so if you keep going through this, I'm going to show you a tool to just more easily browse through the code that we've written and the functions that we've written for you and their descriptions. What we saw before when we looked at time.h and gpio.h was all this comment nonsense over the top. It's kind of in this like annoying way because it's stuck in the code and you have to like read it and scroll and read it and scroll. There's a nice formatted version of this code available on the wiki pages of our repository online. So if you go back to the same place where Raspware was located, and you go over to wiki right here. It says welcome to the Raspware wiki. And here are all the how is your motor type. You never say blah dot something. But you do give that thing to set motor whenever you want to set the motor. So if this is the thing that the initialized motor returns, if blah was, then you'd set blah here, and then you'd set the speed that you want the motor to set go here. And you can see an example of that in motor demo. So init motors creates 2 of these motor types, which you can think of as like keys to accessing the motor. And it puts them in these 2 spots. Motors is an array in the function, in the file. is an array of 12 motor T star types, which you can think of as objects, right? Both of those get returned when you call initialize motor. Initialize motor takes a few parameters, which all of which are described in details on the documentation. And then to actually set that the motor speed of both of those, you see two set motor function calls. You provide the first motor, and you set it to some value called left. Right. The second motor, and you set it to that to a value called right. And those values are set inside the loop. They're set up here, and then depending on how you work the demo, they'll be changed. So that same kind of pattern of using, calling an initialize function, getting something back, and using that something to do other things is used throughout RAS Lib. So when we look at other files here, like, what's a good one? The sonar. So ultrasonic sensors are something we use a lot to ping sensors. You programmed one, I think, in yeah. Something that basically just senses distance using sound. And so we've written a function called initialize sonar. Initialize sonar takes in 2 pins where you plug the sonar into your board, and it returns a T sonar star type. And that's what you would use to do something like, for example,
Does it return an error if you're initializing the sonar twice?
Yep.
No, just returns another sonar. You can initialize however many you want.
Don't do it.
If it's on the same pins, don't do it. You can't initialize any number of sonars.
Yeah, just like you can initialize a number of motors by giving the pins of those motors
Yeah, where do you specify the pins?
in the initializer function. So if you saw,
Yeah,
the initializer function takes 2 pins and a couple more arguments. These are
ADC is limited to which pins it can use, in which case it returns null.
And if you're wondering which pins you should use, I would probably start with the demo project's pins. Those will be the ones that are most updated to the board that we're using. Probably most convenient for you to use. So if you wanted to use 2 motors, for example, I would use these pins for motors.
But it makes
You
a
wanna get-
difference, right?
It does make a difference. You have to plug it into the right place.
Yeah, it's just what I'm saying. Other than that, you just switch to the numbers or letters or whatever.
Well, it does make a difference because the hardware supports those pins specifically.
Okay, so there's more like power output for the motors and everything?
Yes,
Okay.
you can think of it like that. You want to give more details on that?
Okay, well, so ADC is the only one that has a limited hardware block, and that ADC only has certain pins are connected to the part that
And
is
what is ADC referred to?
Analog and digital conversion. It's used in IR sensors. If you look into the IR demo, the functions that it actually uses, like in the demo, if you look into the IR sensor demo, the functions that it uses are ADC.
Okay.
So the IR, in case you're wondering, is infrared. It's something that's it's a laser that shoots out and tells you distance, just like the sonar shoots out sound and reads it back. The IR shoots out a laser, and it tells the board that value based on the voltage of the line that it's sending to the board. And that value is a voltage. It's analog, and you have to convert that to a digital value. So that's why you use ADC to do the conversion from analog to digital. That's why you see
Alright,
ADC.
so it's the rest of it.
Why were we talking about ADC?
Oh, because that's the only one that actually is a special case.
Okay, so when I said hardware, I was also referring to the board that you soldered that you would plug into the launchpad.
So currently the state of RAS Lib is that that is a separate thing, so it doesn't respawn badly for using the wrong pins.
It doesn't.
You'll run into difficulty correcting it, because if you look at the board, the booster board, it actually has certain pins in the part where you connect the board to, running directly to motors.
All right, so the whole point of this was to give you sort of a feel for what's going on in the demo. If you want to get more involved in the demo, run it on your board. All the instructions that you need to know are on the wiki. Are on the README. In the repository, like I showed, you go to the repository page. There's a README document. GitHub actually, I didn't quite explain this, but the README document is right here. But GitHub does this great thing where it detects if you have a README at the top of your directory and then prints it out in pretty format right here. So it's both on the main page of the repository and in the README in the actual repository itself. So if you just follow these instructions, you should be fine. If you run into any trouble, feel free to talk to us. Yeah, and that's basically all I have. Do anyone want to talk about anything else? I don't think so, right? That basically covers it. Yeah. All right. So any questions? Comments? Smart remarks? No? We're good? Yeah.
For the turtle Git, you could use like PowerShell or something?
Oh.
Do the same thing?
Yeah, so what we described was using Tortoise Git, the UI. If you're more of the command line persuasion and you'd rather type out your commands instead, there are several different tools for those. PowerShell works. So PowerShell is the command line tool for Windows. There's command prompts and then there's also PowerShell. You can get to that through GitHub's app. Are you familiar with any of those?
Yeah.
I'm just asking. Okay, yeah. What else? Git Bash is another one. There's a ton of different tools you can use to interface with Git. Some of them involve typing, some of them don't involve typing, and it's another UI. I think I would recommend Git Bash if you want to type out your commands. So look that up.
If you're running Linux, just there's already a command in Git saying that to work out.
If you're running Linux, you'll probably need help getting everything set up. Everything that I've described is mainly under the assumption that you have Windows, because we're using Kyle. Kyle doesn't really work on Linux. So it is possible if you really want to go with Linux, but you're going to probably need help from someone. Any other questions? Everything makes sense? How many of y'all have your boards like ready to go? Basically? No? No? Okay, cool. Once you get the booster pack finished, plug it on.
It is necessary for the LED demo, LED blinking thing.
Yeah. Oh, I should describe that. So basically what we just showed, the LED blinking in the demo, is exactly the thing you need to do in order to get the checkpoint off.
You can't use the demo.
You can't use the demo. You have to use your own project, but you can do something very similar to what's in the demo if you wanted to do that. Hint. Bonus points for coming to the talk. But in order to do that, you have to have everything else installed and set up. So it's a simple programming problem as we can possibly come up with to give you. But you have to have a lot of this infrastructure ready to go. That's why we give it to you. So, yep, I'm done. If you have any questions, stop by the bunker at any time. Ask your mentor. That's what they're for. Yep. Or ask us after.